Okay, so thanks for hopping over to this other video. We are on page 138 in Module 1, Topic 3, Lesson 3, Activity 1 continued. Okay, it says Casey thought using a pattern would help her understand how to calculate the product in a decimal multiplication problem. Casey's pretty smart. It can do that. So we're supposed to fill out this table. I would like to start right here with this, right here, 32 times 1. Because that's really easy for us to do. So what is 32 times 1? It's 32. Now, if we move up, what's 32 times 10? Right, it's 320. And 32 times 100, see, it's the 32, this time with 2 zeros. Okay, so what's 32 times 1/10? I'm hoping that you get it. I'm just kind of waiting. So it's 3 and 2/10. So this is this is a whole number times something in the tenths. So our answer is going to be in the tenths. So like if we had 1 times 1/10, our answer is going to be in the tenths. 32 times 1/100th. So now our answer is going to be 32 hundredths. And then 32 times 1/1000th is going to be 32 thousandths. Now to write that, I know the thousandths place has 3 spaces after the decimal, and I need to write the number 32 in there. So the 2 will go at the end, the 3, and then this gets the 0 right there. Okay, let's move on to the next column. I'm still going to stick right here in this row. 3 and 2/10 times 1. It's still the same thing because it's a times 1. Anything times 1 is the anything. Okay, so as we go up the column, it's 3 and 2/10 times 10. So if we're doing 10 times bigger than this, then our answer is going to be 32. And then 3 and 2/10 times 100. So now if we get 100 times bigger, our answer is going to be 320. Going back down this way, we have 3 and 2/10 times 1/10. So a tenth times a tenth equals 1/100th. So whatever our answer is, should be in hundreds. And if we didn't think about the decimals at all, we just saw 32 and 1, we would say 32. And we know tenths times tenths gives us hundredths, so it has to be there. For the next one, we still have the 32 and the 1. But now we have tenths times hundredths. And I'll put that right here. 1/10 times 1/100 equals 1/1000th. So we know that there's going to be 3 digits after the decimal point for the thousandths place. And then 3 and 2/10 times 1/1000th. So I know I'm going to have the 32. So I have a tens place, so a tenth, and a thousandths place. So 10 times 1,000 is 10,000. Woo! So tenths, hundredths, thousandths, 10,000ths place. Are you noticing any patterns? What happens with this decimal point as we go up and down these columns? I hope you're starting to pick it up. So sticking here in this one, 32 hundredths times 1 is just 32 hundredths. 32 hundredths times 10, so it's going to be 10 times bigger than this. So that's 3 2/10. Then 100 times bigger than this is just simply going to be the number 32. Coming down this way, we have hundredths times tenths, so we know our answer is going to be in thousandths. So it has to look like that. 32 hundredths times 1 100th. So we know it's the 3 times the 2, so we know 32. And then we know it's hundreds times hundredths, so that's going to be, so 100 times 100 in the bottom. So numerator is 1. 100 times 100 is 1, 2, 3, 4 zeros. So it's 10,000s. So for this to be in the 10,000s place, hold on, I just want to make sure that I've got this correct. Yeah, so here's the thousands place, here's the 10,000s place. I was just making sure my pattern was working out correctly, and it is. Okay, so then the last one is 32 times 32 hundredths times 1 1,000th. So I noticed I'm going to have the 32. Hundredths times thousandths. That's going to give me 5 digits after the decimal. Okay, so now it says describe any patterns you notice. So what patterns do you see? So what happens when we go by a higher power of 10? When we multiply by a power of 10 that's higher than the one that we have. Remember, these are all the powers of 10. What happens as we go from 1 to the one above it, to the next higher one, to the next higher one? And think about the decimal point. What is happening? So here the decimal point is followed by 3 numbers. Here it's followed by 2 numbers. Here it's followed by 1 number. Here it's after 2 numbers. Here it follows 3 numbers. Here it follows 4 numbers. So the decimal point seems to be shifting 1 to the right when you multiply by a power of 10. If you're starting all the way down here. Now, if I just look at it from here down, if we go multiply it by a power that's less than 1, then the decimal point looks like it moves 1 to the left. So 30, 32 to 3 2/10 to 32 hundredths to 32 thousandths. And does the same thing hold true for here? Going up, it looks like it goes 1 to the right. The decimal point would be here, then here. And going down, because we're multiplying by something less than 1, goes over 1 there, over 2 other spots, and then for a total of 3. Then it's going to move from here over another one, and we'll have a decimal point in 0032. Same thing really happens in this column as well. If you notice, from here up, the decimal point goes to the right. From here down, it goes 1 to the left. So how do you describe the patterns? So the decimal point moves to the right when multiplied by a power of 10. And then it moves to the left. When multiplied by a power of 10. These are all powers of 10. These are all powers of 10. By a power of 10, that is less than 1. Wish I had a better document camera. I apologize. Pause that if you need to. Number 3, use the fact that 26 times 31 equals 806 to determine each product. Do not use your calculator. Okay, so it says that 26 times 31 is 806. These all have the numbers 26 and 31 in some form. It's just the decimal point that we are considering here. So I'm just going to write 806. 806. I know they're all going to have that number in it. Okay. And I notice another pattern here, and I don't know if anybody else noticed this, but like let's look here, for example, and maybe I can use a highlighter on this. In this question, for example, there's one digit that's after the decimal point in these factors. And in my product, there's one digit after the decimal point. And this one, there's two digits, or two numbers is what we mean by a digit, two numbers that are after the decimal point. And my answer had two digits after the decimal point. Let's check that out maybe over here where we have a decimal in the first factor as well. So let's look at 3 and 2/10. So there's one number after the decimal point times 1/10. There's another one number after the decimal point. But altogether we had 2. 1 plus 1 is 2. So two numbers after the decimal point. Let's try this one. Two numbers after the decimal point. Two numbers after the decimal point. 2 plus 2 is 4. We do, in fact, have 4 numbers after the decimal point. Let's try this one. One number after the decimal point. 3 numbers after the decimal point. 1 plus 3 is 4. In fact, we had 4 numbers after the decimal point. So I'm going to use that information as well as the patterns in here and just think about these questions. So 2 and 6/10 times 31. I see one number after the decimal point. If I find a question that looked similar to that, like let's say here, so we have a whole number times something that has a tenth. Here's where our answer was in this one. So our answer here had tenths. So if our answer's with tenths, then my decimal point would go there. Does that align with what we just did with the highlighting? There's one number after the decimal point. In this factor, there's none here, so 1 plus 0 is 1. We, in fact, have one number after the decimal point. 2 and 6/10 times 3 and 1/10, so 2 decimals with tenths. So tenths, tenths, and our final answer was in hundredths. So if our answer is in hundredths, then that decimal point needs to go right there between the 8 and the 0. And then let's check that. There's one number after the decimal point. In this factor, one number after the decimal point in this, 1 plus 1 is 2. We have two numbers after the decimal point. Please pause, finish this, and see if you can answer number 4. I'm going to pause the video as well. I'll come right back. Okay, welcome back. So here I have hundredths times tenths. Hundredths times tenths would be thousandths, so I think it should be here. Let's try this out another way. We have two numbers after the decimal, one number after the decimal for a total of 3. We do in fact have 3 numbers after the decimal. If I looked for that up here in the table, that would look like this one. Hundredths times something with tenths, and your answer is in thousandths, and so is that one, so that is correct. Okay, this one we have one number after the decimal point, two numbers after the decimal point. So there should be a total of 3 numbers after the decimal point. Well, wait a minute. We just got the same answer. Is there a reason why? We got 806 thousandths. I have 26 hundredths times 3 and 1/10. I have 2 and 6/10 times 31 hundredths. So both of these expressions have 3 numbers after the decimal point here total. So I'm guessing that I could say, I think we can make a kind of a summary statement for that, but let's do a few others first here. So we have 2 numbers after the decimal point and none. So 2 numbers after the decimal point. So let's think about that and check it with our table. So we have a whole number and something with 2 decimal places, and it's in hundredths. Okay. 2 and 6/10 times 31 thousandths. So we have tenths times thousandths, so we should get 10 thousandths. Let's look at our table. Let's see, we have a 1 number after and 3 numbers after. So 1 number after the decimal point, 3 numbers after the decimal point, a total of 4 numbers after the decimal point. And is that what we see here? 1 number, 2, 3, 4 numbers after the decimal point. Well, here's 3 of them. So I'm going to have to squeeze a 0 in there so I can have 4 numbers. Okay, this one has 1, 2, 3, 4, 5 numbers after the decimal point. And that aligns with this. 2 numbers, 3 numbers, 5 numbers after the decimal point. So these decimal points are very tiny in this book. So there's, I don't know if you can even see it on mine, 26 thousandths times 31 hundredths. Okay, last one. 2 numbers after the decimal point, 2 numbers after the decimal point. So that's a total of 4 numbers after the decimal point. So I see some numbers that look the same. So, for example, each of these are in thousandths. And this has 1, 2, 3 numbers after the decimal point, 1, 2, 3. I think we might be onto something. Let's see. How about let's compare. Let's get a different color here. Let's compare this one and this one, because these are both 806 ten thousandths. So there's 1, 2, 3, 4 numbers after the decimal point. Do I have 4 numbers after the decimal point here altogether? 2 and 2, which is 4. So even though I start with numbers that have a different form of the decimal with these numbers, 2 and 6/10 versus 26 hundredths, 31 thousandths versus 31 hundredths. So we're using the same digits. We're just locating the decimal point in a different place in the factors. But because there's 2 here and 1 here, but then in this one, there's 3 here and 2 here. That means this one has a total of 4 numbers after the decimal, as does this one. So that's why those are the same. Okay, let's answer the bottom question. It says, look at the pattern in question 3. How can you tell without multiplying which expressions will have the same product? So we can say, I can look at the sum of the decimal places, I guess would be good. Of both factors. Expressions that have the same total number of decimal places will have the same product. Okay, and I'm going to pause there. This video is plenty long. You can go ahead and pause if you need to fill that out, and we'll see you on the next video.